So this is part one of the notes for section 8.2, special right triangles. The objectives will just be that we'll be talking about the properties of the 45, 45, 90 triangle. It's called 45, 45, 90 because those are the three angles that are in the triangle. We have two 45 degrees and one 90 degree. So we should remember a lot of things from this triangle. It's a very good review. First off, we have to know that it's an isosceles triangle because we have two angles that are congruent. So you should remember across from the congruent angles have to be the same measure. So you'll oftentimes see x and x. To find the hypotenuse, we can use the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. Well, for a and b, we have x. So x squared plus x squared is equal to c squared. We combine like terms, so that's going to be 2x squared is equal to c squared. And then to find the hypotenuse, we would take the square root. So remember, if we break down the prime factors, we have 2 times x. Well, there's a pair that comes out. So what we have is c is equal to x square root of 2. A lot of you might not like that notation. But this figure that we have right here will actually be on your SAT as a formula that will be given to you, which means that it's almost always on the SAT. So it's something you'll be seeing again later on as you continue to take math. Another way that we can take a look at this is kind of by using this chart. So we can think about similar triangles and they're in this ratio. So let me explain a little bit more. If I take a 45, 45, 90 triangle, and let's say I have legs of 1, I know the hypotenuse has to be the square root of 2. So this is an actual 45, 45, 90 triangle. And that means that anything that I want to take a look at, so let's take a look at one of our examples. So if I look at example 1 here, I have a 45, 45, 90 triangle. And the lengths that I'm given a leg of 8 and the hypotenuse of x. So our strategy before, whenever we did similar triangles, so think similar triangles. By the way, these are similar triangles because of angle-angle similarity. We have two angles that are the same, 90 and 45, 90 and 45. So we also know that the sides have to be in proportion. So the sides are in proportion. So we use that strategy from before where we take one triangle. So the sides I'm really concerned with are 8 and x. So I take that one triangle, 8 and x, and I put it over the corresponding sides. That's just 1 and the square root of 2. Then I cross multiply. I get x is equal to 8 times the square root of 2. That's it. That's going to be my answer for number 1. So what you see a lot is that people will make this chart. So if I would make this chart here, I would have LLH, 1, 1, square root of 2. And I know both legs need to be 8. And then I would just cross multiply with x here. So that's one way to do it. I actually prefer to just have you write out the similar triangle each time. So if we would do that for number 2, we have legs here, so it's 1, 1, square root of 2. So the sides I'm concerned with are these two sides right here, a leg and a hypotenuse. So we have 1, square root of 2, and we set it over our actual numbers here. So we have x and 3 times the square root of 2. So you might be thinking about cross multiplying. It's a little bit difficult, but if you think back to what you know about fractions, the square root of 2 over the square root of 2 is just 1 over 1, so those kind of go away. So now whenever I cross multiply, it's easy. X is equal to 3. We'll have more problems like this in class, so if I'm going a little bit too fast, don't worry about it. And hopefully you're starting to get the picture. So again, I have a 45, 45, 90. I know that because this is an equilateral triangle. It's a right triangle, so the two angles would need to be congruent. So what I have here is x and 18. And remember, this was 1, 1, square root of 2. The two legs are 1. So underneath x goes the square root of 2. Underneath 18 is 1. So I have x is equal to 18 times the square root of 2. And lastly, we'll do number 4. Again, we have another 45, 45, 90 triangle. These only work on 45, 45, 90 triangles. So I have 6 square root of 18 and x. I need to remember the side lengths. 1, 1, square root of 2. 1 and the square root of 2. This might throw you off a little bit. X is easy, and then I have 6. And then remember, I multiply 18 and 2. It's under the square root. It's pretty easy with a calculator. So it's 6 times the square root of 36. And hopefully you all know that the square root of 36 is 6. So x will be equal to 36. Like I said, hopefully that made sense. Think back to similar triangles if you're stuck. This is one triangle, and it's similar to all those triangles, numbers 1 through 4. And hopefully that would be enough to make sense for you.